In this video, we solved problem 10.1.19-T from Essentials of Statistics, 6th edition by Mario Triola. The problem statement says that listed below are annual data for various years. The data are weights in metric tons of imported lemons and car crash fatality rates per 100,000 from the population. We're asked to construct a scatter plot and find the value of the linear correlation coefficient R and find the p-value using an alpha or significance level of 0.05. And the question says, is there sufficient evidence to conclude that there's a linear correlation between lemon imports and crash fatality rates? And then they ask, do the results suggest that imported lemons cause car fatalities? I think that we know that no matter what, regardless of whether there's a correlation between those two things, we know that lemons do not cause fatalities. So let's go through this. This time I'm going to use technology pretty extensively to do the whole problem, and I'll show you how quick and easy it is if we aren't using hand calculations to compute all of this. I'll be using Excel for all of my calculations. First, we're asked for the null and alternative hypotheses. Now, the claim is that there's a linear correlation between the two variables. So the null hypothesis is that there's no correlation. The alternative hypothesis is that there is a correlation. And we're not saying that the correlation has to be a positive correlation or a negative correlation. So the null is that rho is equal to 0, and the alternative hypothesis is that rho is not equal to 0. So that's D. Great. And then we're asked to construct a scatter plot, and we're given all of these scatter plots. Now, I could just look for these ordered pairs on these 4 graphs and use process of elimination to determine which graph is appropriate. But if I'm using technology, I would click right here, then go to open in Excel. So when I open this in Excel, this is what I see, and I want to construct a scatter plot. So I will just select these cells, then go to Insert. Then I see a little scatter plot image, then I choose the first one, and I see something that looks like this. Now I always like to make it square because the options on MyLab Statistics are always square. And so I'm looking for a pattern that kind of looks like this. Notice that the X values, those are the lemon imports are on the X axis. You always want to make sure that the axes are correct. For some reason, for a while, my Excel was inverting the X and Y axes every time. Now it's back to normal though. So the only graph that looks remotely like that is option D. Great. Now we're asked for the linear correlation coefficient, and we're asked to round to 3 decimal places as needed. I will do this in Excel as well. So when I'm in Excel, I type equals, and then I type Pearson. That's giving me that Pearson correlation coefficient R. And then it asks for the first array and the second array. For the first array, you want to select your X values and then type a comma. And then for the second array, you want to select your Y values. And then close parentheses, and then it'll give you that value of R. So we have an R value of approximately 0.931 if I round to 3 decimal places. So we'll type that in over here, negative 0.931. Great. And then they ask for our test statistic. To compute the test statistic, I will share my paper with you, and then we'll use Excel to do the computation. Now remember, the test statistic T is a t-score that corresponds to this sample statistic R. And to find that test statistic T, we just use this formula. N is the number of ordered pairs we have. We have n minus 2 degrees of freedom. And then we use the value of R that we computed earlier here and here. And that's going to give us a T value from a student T distribution with this number of degrees of freedom. So in order to actually compute that, I'm going to use Excel. So for our T value, we type equals, then we select the R value, then we divide by the square root of open parentheses for the numerator, open the parentheses for the argument of the square root, and then open the parentheses for the numerator. And we have 1 minus r squared. So I'll select my r and I'll square it, close parentheses for the numerator, and then divide by 2 less than the sample size. We've got 5 ordered pairs here. So 2 less than that is 3. And then you close parentheses for the argument of the square root and hit return. And I get a t-score of approximately negative 4.410 if I round to 3 decimal places. Now I have to go back to MyLab Statistics and see if they want us to round to 3 decimal places or 2 decimal places this time. And it looks like they want us to round to 3 decimal places. So we'll type negative 4.410. And then it asks for the p-value. Now, because our alternative hypothesis was just that there is no population, or our alternative hypothesis is that there is this linear correlation coefficient rho for the population. We're saying that that is non-zero in our alternative hypothesis. Since that has a not equal to sign in it, that means we're dealing with a two-tailed test, which means our p-value is the area in 2 tails for a test statistic like ours of negative 4.410, or a test statistic that is more extreme than that. That's that probability, and that's the p-value. So let's use Excel to find that p-value now. This is very simple. Just type equals, and then you can type t.dist. Oops. And then since we're looking for a two-tailed test, I would type 2t afterwards. And then open parentheses, and it wants the test statistic. So we'll select that, the number of degrees of freedom, which we know to be 3. Oops, and it does not like that one. For some reason, it's giving us a hard time. So maybe we will use the t.dist, that distribution. That's going to give me the area to the left of this test statistic t. If I have 3 degrees of freedom, I want to say true for area to the left. And actually, I want to double that. I don't know why the two-tailed distribution is not working this time. But we have a 0.0216. So if we round to 3 decimal places, that'll be 0.022. Like, did I type something incorrectly? B10, two-tail. I don't know. For some reason, it didn't like that. Oh well. I can still get the p-value this way. That's fine. So our p-value is approximately 0.022 if I round to 3 decimal places. So we'll type that in here. Great. And then we compare it to the alpha value, that significance level of 0.05. Well, 0.022 is less than the significance level. So that means that this value of our test statistic t, which corresponds to the value of that sample statistic r, is improbable, given that the null hypothesis is true. So we will reject the null hypothesis. And that means there is sufficient evidence to support the claim that we have a linear correlation between lemon imports and car crash fatality rates at that particular significance level. Okay, now the last question says, do the results suggest that imported lemons cause car fatalities? Does having more imported lemons cause people to die in car crashes? No. There is no cause or effect relationship implied by correlation. So D is our answer. It says the results do not suggest any cause and effect relationship between the 2 variables. And that's it.